Have you ever stopped to think about what connects the light from a star billions of miles away to the Wi-Fi signal in your living room? Well, they're both part of this massive, invisible world of waves that surrounds us. Today, we're going to dig into the incredible story of how a tiny, single flaw in a 19th century law ended up revealing this entire hidden universe. Right, so look at these three things: Wi-Fi, the warmth from the sun, and a medical X-ray. You'd think they have absolutely nothing in common, but it turns out they are all just different flavors of the exact same fundamental force. And the key to figuring that out? Well, it all started with a tiny, overlooked problem in what everyone thought was a perfect law of physics.
So back in the 19th century, physicists were trying to figure out the deep connection between electricity and magnetism. And Ampere's law was like a cornerstone of this whole thing. It's a simple, really elegant rule. Run an electric current through a wire, and it creates a magnetic field around that wire. Simple. It worked every single time, or so they thought.
Okay, so here's where things got weird. The problem came from a device called a capacitor, which is basically just two metal plates with a gap in between them. Now, out in the wire, where current is flowing, Ampere's law works perfectly. You get a magnetic field, just as predicted. But then you look at the gap between the plates. There is no current flowing across that gap, right? So the law said there should be zero magnetic field there. The only problem? Experiments showed there was one, a big one.
This was the question that had physicists completely stumped. I mean, how could a magnetic field just pop into existence out of thin air? It seemed to violate a fundamental law of the universe. It was a real puzzle, and it was going to take a stroke of absolute genius to solve it.
And that genius was a guy named James Clerk Maxwell. He came up with this brilliant, elegant idea. He said, okay, you're right, no charges are physically crossing the gap. But as the capacitor charges up, the electric field in that gap is changing. And he proposed that this changing electric field could itself act like a current. He called it a displacement current. And that was what was creating the mysterious magnetic field. It was the missing piece.
But here is where it goes from a clever fix to a universe-altering revelation. Maxwell realized this wasn't just some weird thing that happens in capacitors. This was a fundamental rule of nature. A changing electric field creates a changing magnetic field. But then, that changing magnetic field creates a new changing electric field a little further out. And that one creates another magnetic field, and so on. It's this incredible, self-sustaining chain reaction of fields rippling out into space.
So Maxwell took all the known laws of electricity and magnetism, added his new concept of this displacement current, and he stitched them all together into one beautiful, unified set of equations. I mean, this was already huge, unifying two of nature's forces into a single framework. But what these equations predicted, well, it was going to change everything.
The math was undeniable. It predicted that this chain reaction of fields would travel outward as a wave, an electromagnetic wave. Now, this was a totally radical idea. See, other waves, like sound, need air to travel through. Ocean waves need water. But these waves, they didn't need anything. They could travel through the total, complete vacuum of empty space all by themselves.
But Maxwell wasn't done. He decided to take it one step further. He said, okay, if these waves are real, how fast do they go? So he took two numbers from completely separate lab experiments, one that measured the strength of electric forces and another that measured the strength of magnetic forces, and he plugged them into his brand new equations.
And the number that popped out was this: 300 million meters per second. Now that is just a ridiculously fast speed. But to Maxwell and the other physicists of his day, that number was instantly, shockingly familiar.
It was the speed of light. The speed of his purely theoretical wave, calculated from tabletop experiments with electricity and magnetism, perfectly matched the measured speed of light. The conclusion was just inescapable. As Maxwell himself put it, quote, "We have strong reason to conclude that light itself is an electromagnetic disturbance." He had solved the ancient mystery of what light actually is.
And get this, Maxwell's theory didn't just explain visible light. It predicted an entire vast spectrum of these waves, a kind of invisible rainbow, where each type of wave is just a different wavelength and frequency. So let's take a super quick tour through this amazing electromagnetic spectrum he uncovered. On the super long wavelength, low frequency end, you've got radio waves. These things are the absolute backbone of our modern communication systems. They carry everything from AM/FM radio to TV signals to the data on your cell phone.
Next up, you have microwaves. Their wavelength is perfect for a bunch of things, from radar systems to, the oven in your kitchen that heats up food by making water molecules vibrate like crazy. And of course, they're the waves that carry the Wi-Fi signal that is probably delivering this to you right now.
Moving up in frequency, we get to infrared. You and I experience this mostly as heat. It's what heat lamps use, it's what thermal cameras see in the dark, and it's that little invisible pulse of light that your TV remote uses to change the channel. And then we get to this tiny, tiny little slice of the whole spectrum. This is visible light. It's the only part our eyes have evolved to be able to detect. Every single thing you have ever seen with your own eyes, every color, every sunrise, exists right here in this narrow little band. Kind of wild, right?
Now, as the wavelengths get shorter, the waves get packed with more and more energy. We get into ultraviolet or UV light, the kind from the sun that gives you a sunburn but is also useful for sterilizing equipment. Then you've got X-rays, which are so energetic they can pass right through your skin, letting us see your bones. And at the very top, you have gamma rays, which are so powerful we use them in medicine to destroy cancer cells.
Maxwell's theory back in 1865 was the spark that lit the fire. Just about 20 years later, a physicist named Heinrich Hertz actually generated and detected radio waves in his lab, proving Maxwell was right all along. And from there, the floodgates opened. Innovators like Bose and Marconi quickly figured out how to harness these waves, leading directly to the invention of radio and kicking off the entire wireless age. So think about that, our entire modern connected world. Your phone, your Wi-Fi, the GPS in your car, medical imaging, all of it can be traced back to one scientist who noticed a small crack in an equation and just couldn't let it go. It's a legacy that even helped pave the way for Einstein. And it really makes you wonder, doesn't it? What other little puzzles are physicists working on today that might just unlock the next hidden layer of our universe? Thanks for joining me for this one.